Welcome, everyone, and it's very nice to have you all with us today. We are really happy to have with us Shuwei Chen. I hope I didn't butcher your name. He started working on this project that now is at Alluxio for unified data analytics and AI way before the project was actually under the umbrella of Alluxio. And so, Shawei, would you like to say a few words about yourself to introduce also the conversation?
Sure. Thanks, Gabriel, for the introduction. Hello, everyone. I'm really happy to share our story at the Unified Data Analytics and AI on the AnyStack and cloud. And my name is Shouwei. I have the really short Bible to introduce myself. I'm the co-maintainer at the Alluxio, this open source project. And at the same time, I'm the community product manager. And before joining Alluxio, I received my PhD degree at Carnegie University and mainly focus on the distributed in-memory file system, distributed in-memory computing framework.
Cool. So you were here in Jersey for a while.
Yeah, I have been there for 6 years. Yeah.
6 years. Wow. Yeah. My parents went to Rutgers, actually.
Oh, nice to
Yeah.
Yeah.
Nice.
And actually, just to let you know, Alluxio is an open source project. It actually starts from UC Berkeley AMP Lab. It's like a very famous lab in the academia, also in the industry. And this project is start from 2014. And until now, we have like more than 1,200 contributors, and this number is keep growing these days. And otherwise, we also get a lot of recognition by the other ranking. For example, the Google rank us as a top 10 most critical Java-based open source project in the world. And we also the top 100 most valuable response out of 96 million of the GitHub repo. Before we dive into the detail of the technical and the use cases analysis, I want to throw one question here. It's why nowadays, because actually we are aiming for the unified data analytics and AI. So that's one question we want to answer is why are data platforms these days are so complex? The first of all, we'd like some look at into some common pitfall we observed. The first of all is that more and more data is being generated. Data is stored in siloed. Which means siloed is that you can store it in the different storage system in the different location and anywhere you want to store the data. And it's lead to you want to copy and manage your data all over the piece. It's very costly and error prone and cause many delays for your data analytics and AI. The second issue is that many different teams need access to this data. So that means it's not because not only your data source is like data siloed, but actually your request is also siloed. This is the need to support, this means you have to support new applications and support the corresponding different interface to access the data. It will take super long time to stabilize this kind of interface and this kind of applications. And on top of that, our tech industry is progressing very fast, which has been creating new compute and storage technology every 3 to 8 years. You know, like 20 years, maybe 30 years ago, is the world of the traditional database like MySQL or like MongoDB or this kind of thing. But nowadays, people like transfer to the big data world like Hive, nowadays Spark, and the Flink, all these kind of tools. So actually, like everything is a revolution now. So it's very costly for you to maintain and treat this kind of revolution. This is a traditional data infrastructure may look like or evolve into something like this. It's very complex and slow down your business agilities. In many cases, the data infrastructure starts with the on-premise environment for analytics. For example, you have your own data center and you want to do your things at your own data center. And it's as duplicated by the box on the bottom left of this page. For example, you have the traditional Hadoop ecosystem with a different component there. But then many data team, especially the data team, like start to introduce new kind of application, like machine learning, kind of like a new storage solution suited for the application. For example, previous people always use HDFS, but nowadays people using S3, using GCS, they even use like MinIO or Ceph in the cloud. Actually, it's very complex. And you can just see at the box at the right bottom, actually introduce a new computing framework, and you also introduce a new storage system, because your data pipeline very complex there. And finally, the adoption of the single or multi-cloud adds even more environment to management, because people always want to say, like, if we like fall into the AWS environment, like I cannot you cannot get like a discount from this like big cloud vendor. So people want to say, like, I can negotiate together with AWS and Google Cloud to get more benefits. So they don't want to lock into one cloud vendor in many cases. Okay, because of all these reasons, actually there is very strong demand of simplification. First, there is a new need for the unified data silo, support multiple APIs and common user queries to meet the demands of analytics and AI application. Second, with the storage separate from compute, the platform need to provide easy and efficient access to data, regardless the data where it is. It can be at for example, Italy, it can be at Palo Alto, it also can be the New York. People want to get very constant performance and user experience with this kind of data. And lastly, the solution need to be environment agnostic and multi-cloud ready to accommodate the future state of the computing and technology. That means no matter where you do your data analytics, where you do your AI, it should be the same. Okay, with all these demands in mind, we introduced a new layer between the computer engine and the storage system. We call it Alluxio, and it's for the analytics AI in the hybrid and multi-cloud domain. And the new layer provides a complete virtualization across all data sources to serve data to applications who do not need to care about the location of the data. And this solution we build is applicable across the environment, whether in the cloud or on-premise, bare metal or containerized environment.
I wonder, Shoei, if people in chat, I guess if you're dealing with this problem right now, if you just want to comment in chat if this is something you're facing, or if you've heard of Alluxio before and have tried it. I guess it would be interesting to know how everybody relates, right, to the problem and where you're all coming from. So if anybody wants to share.
Feel free to leave any question at chat, and also maybe you can just speak out your question to me. Okay. After all this kind of question, actually now let's look at what is our version of this updated data platform. Nowadays you can see the key difference is that Alluxio in the middle. The complexity of the manager's data among the various silos is removed. So that means you don't need to like take care about HDFS, GCS, S3 by yourself. Alluxio will take care of it. And in each different environment, as long as application interact with Alluxio, I mean, user don't need to worry about where the data is stored and how to move the data around. You don't need to do any manual work to replicate your data, move your data, and do the verification of all of this kind of thing. And other things like, for example, if you're onboarding your new applications, actually you also don't need to worry about it, because actually we almost support most of the interface, including HDFS compatible, S3, and Fuse for all these kind of applications. Okay, nowadays it's like thousands of companies actually using Alluxio in their production environment, including 7 out of 10 largest companies by marketing capacity and 8 of the top 10 largest internet companies. And we have seen a very success across verticals with the technical community leading the way. And we also see it's growing more and more in the finance and telecom and the media, all this kind of different domain. I want to stop here for a little bit, and I will dive into the architecture overview afterward. If you guys have any questions.
I'm interested in right now, one of the places where we are producing a lot of data is the edge. Is this something that can run also at the edge? And I'm asking this more in terms of the footprints than because if it runs on Kubernetes, or like, I guess I could just deploy in any cluster.
Yeah. It's a very, maybe let me repeat the question. The question you're asking is like, if is anyone using the Alluxio in the edge computing, right? And yeah, actually it's a very good question. And actually nowadays we not emphasize that, but actually we did see like people using Alluxio in the edge computing. Because just to give you an example here, actually we collaborated with the utility about some like astronomy data from the Mexico, the edge. Then people want to consume at the university at the United States. Actually, this is kind of the edge computing we support at this moment. But we are not doing any computation there, but we just move the data from the edge back to your main cloud storage like S3, TCS, all this kind of thing.
Okay, so it's really a good way to transport the data and eventually to also be more, let's say, shielded by the issues of communication and all of the copies and the problems that you were saying before. Thank you.
Yes, it's correct. Yeah, thank you for the question. And after that, we want to go to the overview of the architecture to see how we can enable a hybrid data lake here. Alluxio, it's like we have several different components for our software. First of all, we have the Alluxio master here to make sure like we can serve all these kind of file systems metadata request, and it also guarantees the high availability for the Alluxio master. For example, you're done with some server, actually we can recover it from another server to guarantee that you have the maximum availability for your software. And otherwise, we have the Alluxio workers here. Actually, it can deploy with any kind of media there, like RAM disk, SSD, HDD, and to provide the tiered storage and provide the high performance local access to the client. The client usually embedded into the computing framework. For example, we embedded to the Presto, embedded to Spark, and actually with this kind of thing, actually they talk together. Then can access data from the local Alluxio cache instead of from the remote cloud storage. First of all, let's talk about a little bit about data locality with scale out workers. For the workers, actually, it's very easy for you to do the deployment and also for the management. First of all, Alluxio workers support the different media, and not only like you only can select the RAM disk, SSD, or HDD. Actually, you can combine them together and to maximum your capability and also the speed for your system. At the same time, you can very easy to scale it out. Like you can just add the worker or scale in with the removed worker, and all the even lost the file, actually it will fetch again from the on the file system to guarantee you are not losing data. The second part is actually we design the Alluxio master in very scaled way, and not like many systems like they only store the metadata in memory. We also use RocksDB to enable to store all this kind of metadata at SSD or like DD. Sorry, did anyone ask questions? Okay, and in this way, actually, we can serve pretty fast like metadata to the up layer computation, including the Spark, Presto, and TensorFlow and PyTorch. This is the unified namespace is one of our key feature to enable like simplify your management of your system. Just imagine like you have many different storage underneath. For example, you have the S3, you have the GCS, you have the HDFS, and you have min.io self with a different organization. At the same time, you want to unify to access it. The only thing you need to do is like mount all this kind of paths from the under file system to the Alluxio system. So that means Alluxio will help. Previously, you have to access, for example, S3 with a schema, min.io with schema. And nowadays, you only need to access with Alluxio schema and with all this kind of paths. For example, you can access S3 region US West 1 with a data path, and you can access the S3 region US East 1 with the root path. At the meantime, because actually we noticed like people have a lot of different requirements based on the different needs. Actually, we provide several different deployment approaches recommend to the users. The first of all, you can co-locate it to deploy your application together with Alluxio, which means you want to achieve the maximum performance of this. That means like you will short circuit your read and write, and it directly will read from the local Alluxio worker. At the same time, if you want to maximum to share the cache, just to give an example, you only want to do the across region data caching, so you don't need to deploy Alluxio worker co-locate with the Spark executor or Presto splits. You only need to disaggregate it and serve the shared cache to all these kind of applications. Yeah, I want to also stop here for a while. Do you guys have any question? Okay, and the next part is a more interesting one. Like we will show the real use cases, and this is how Expedia use Alluxio to build their called unified data lake across multi-geo region in the cloud. I just give a short introduction here in case anyone don't know Expedia. Expedia Group is an American online travel shopping company for consumer and small business travel. Actually, their data infrastructure team built a petabyte scale data platform used by the different terms. They called like brand word. The reason they called brand word is because in Expedia Group, they have a family of the brands such as hotels.com and the VRBO and many other acquired brands that operate independently. Actually, because of this issue, because of this reality, it created the data silos problem for them. With the rise of the data-driven application, the data platform need to support applications that generate and consume data across geographically regions as well as cross-brand. That means actually it will cross a different team and also across the distance, the physical distance. That's why they are building a data platform that aim to breaking these silos called Unified Data Lake. And I would like to give more detail about how they solve this problem before and after Alluxio. Actually, before they introduce the Alluxio into their system, they have an open source project called Circle String. Actually, it's developed by hotels.com. They're aiming to migrating and replicating very large Apache Hive dataset between cluster and cloud. Actually, this tool is used for enable off-promise migration, hybrid cloud architecture, and it's also aimed for the disaster recovery strategies. And it replicates the Hive table between the cluster on requests. Just to give you one example here, if you have the two regions, for one region is located at US East 1, and one region located at US West 2. Actually, just to give you an example here, it's like hotels.com data is at US West 2, and the Expedia Group data is at US East 1. Because of some legacy, and because they run independently, they cannot move all this kind of data from the one region to another. So when they want to consume this data, they have to do the replication from the region, the satellite region US West 2 to the main region called US West East 1. This is the way how they solve the problem. And this diagram shows the architecture of the data replication with cruise string. They have a main data lake in the US East 1 region, and each brand has historical data in their own data lake. Nowadays, like new data is ingested into the US East 1, but what they told me is like it's still very hard because you cannot finish the migration fully. So that means they still have to ingest data in the satellite data center, although like they want all new ingesting into the main region. So actually, because of this architecture, it's caused several different problems. The first problem is actually it's the availability issue and also the poor performance issue. I mean, when you want to have a replication, means that data is not immediately available. So it's not easy to extract value from data at scale on time. Analytics, it can take like a few hours or even a whole days to finish the transformation and replication. And especially the size of table is at the terabytes level. And sometimes it's like can be like hundreds of terabytes level, and the time can even longer. So at the same time, end users are often unaware of the data readiness, resulting in very poor user experience and complaints. Just to give you an example, like you start to transfer the data, but when it's done or not done, you don't know until you dive into the data and check in there. So it's cause a lot of problems there. Another problem is for the error prone. Actually, replication is error prone because data synchronization and validation are all manually. So after you kick off the data replication, and afterward you have to do the data validation. You don't want to give the wrong data to your user and customer. So that means they involve a lot of cost for the maintenance for all this kind of data, which makes them have to hire more people and spend more money on the validation for all this kind of thing. The third one is high S3 ingress cost. Because the data is located in various regions, they have to copy the entire table to the main data lake in order to have the corresponding data available up to date. And at the same time, in realistic, like it's very hard for you to copy only one partition or two partitions to the main region. Most of the time, they have to copy the full table from the satellite region to the main region, which costs a lot of like money spent on this kind of across region data transfer and the data replication. Okay, so after Alluxio, what does it look like? Actually, as the previous mentioned, like they have to do all this kind of thing to move the data, to replicate data. And nowadays, like it's simple as like you just mount the S3 bucket into Alluxio namespace. As we introduced before, the only thing you need to do is like mount the certain paths from the underlayer file system, for example, S3 -- like showaway or whatever, and mount into Alluxio path. Then your application at the US East 1 and with Hive, Spark, Trino, Databricks, actually all these kind of things can access the Alluxio. Yeah, this is
the data. Shall we? Just a question. So the data, if you go back one slide, so the data it's staying in the other regions. It's not automatically replicated. It's not replicated, and Alluxio is connecting to the data at the sources.
Yeah, actually, it's a very good question. Actually, it's dependent two different layers. The first layer is a metadata layer. So that means for the metadata, actually, Alluxio will respond to keep this metadata up to date, make sure it's consistent. And for the data part, until you access the data, we will never read the data. Just to give you an example here, previously Expedia have to copy the full table from the US West 2 to US East 1. For example, it's like 100 terabytes. And for one table, but actually the only data they want to access maybe just past the week, past the month, even past the day data. So maybe just like 1% or even 5% of the full data set. So Alluxio only will read this 5% or 1% of data from the across the region to your main region here. For example, from the US west to the US East 1. And after that, we will keep the data there as a caching. And next time, if your data is never changed, it will still read from the main region to reduce the cost. We still will move the data, but actually we are not do the replication, and we almost the zero copy in some sense.
Interesting. Okay, cool. So Alluxio is basically whenever an application wants to read data, Alluxio will find the data in the right location based on the metadata, and then only replicate the necessary data, and then that will be cached in the main data lake.
Yeah, that's correct.
Okay, wow, nice.
And this is a new architecture nowadays. Actually, they build Alluxio for their main data lake region called US-1. But I checked with them last week. Actually, they also built different Alluxio clusters in a different region at this moment. As I mentioned before, it's not realistic like for you to force all these brands to use the main region. They still want to use the US West too sometimes. And with this architecture, actually, they mentioned that they get 3 different benefits. The first of all, it's greatly enhanced the query performance. So data nowadays is immediately available to user without you need to wait for the long process of the manual check and manual replication and all this kind of thing. It's usually like less than several minutes for your data availability compared to previous like several hours, even a whole day. And because all this kind of hot data set is cached, you don't need to make the S3 increase cost a lot. So just to give you very straightforward, the number is that, for example, you increase the data like 1 terabyte of the data into S3, your read maybe like can be tens or even 100 times larger than that data set. So it's very costly. And nowadays, like they save a lot of money because of that. And the second point is the easy of the management. By integrate of Alluxio, you can now combine the data lake from the data in S3 in different regions without need to manually replicate or move the data anymore. And it simplifies the process of setting up fine-grained access and control for the security and also for the data at the cluster level. And the third one, actually, they mentioned the significant cost saving. This saving is not only for the S3 increase cost, but also because you speed up the Presto data break or AI training. Actually, you use less EC2 instance compared to you used before. And they mentioned it's approximately like reduce 50% of the cost reduction per query for cross data centers, across data center queries. Yeah. That's all we have today. And just to give some advertisement here. And if you're interested in our project, please visit our website and our GitHub, and also join our Slack. Actually, we are very active there. And we also post the event at Twitter and LinkedIn. Yeah, it's a QA time. Any question?
Yeah, feel free to unmute or put a question in chat. You definitely have some positive feedback from Lena Xiaowei that it was a great presentation. I totally agree. This is really cool.
Yes, thank you.
I am not really clear, but that is because my ignorance on this topic, unfortunately. Let's say that you have different type of sources for your data, and one of these are like streaming of events.
Mm-hmm.
Would that be something? And of course, at the end of the day, this would be like data that's saved someplace. Would that be also a use case for like to use Alluxio, like in the idea? And I'm still thinking about an edge situation where at some time like we have a bad connectivity between the edge location and the data center. Eventually there can be offline time. So at some point you will need to synchronize the data that was produced at the edge and synchronize this on the data center. Would that be a use case or do you see a situation like that where it's the Q engine itself that's going to do the replication?
Sure. Maybe I repeat the question, like what is the use cases for Alluxio to integrate with the streaming processing, especially when you ingest the data from the streaming? Is that
Yes.
correct?
Yes.
Yeah. Actually, it's a very good question. I know. I mean, nowadays people talk about streaming, meaning you are talking about the Kafka or Flink, all this kind of stream processing frameworks. Technically, yes, actually you can integrate this kind of data framework together with Alluxio. We provide the interface, and you can just write your data into the Alluxio as a write cache, and we can respond for example, synchronously or asynchronously write back to your data lake or data warehouse to speed up all this kind of thing. Yes, but in realistic, people not really using in this way. Just the reason is because like if you want to do this, actually you increase a lot of cost for this kind of thing, which means that you have to have another layer to do it. And at other perspective, because the current data platform still like evoluting. So that means that people still you get used to when you want to consume the data from streaming, they will ingest to data into their data warehouse, do the ETL job, and cleaning the data, then serve to the applications. They still in this way. But we also see a lot of use cases. For example, we cooperate with Uber. Actually, they are using Foodie at this moment. After they ingest the data into the Foodie table every 5 minutes, actually they will use the Presto with Alluxio to query all this kind of data to speed up the access. So the answer is like not many people using this way, but actually it's have very good feature that we can explore together with the community.
Thank you.
When was the company founded?
We founded at 2015.
Oh, okay.
And actually, previously, it's a like a very interesting story. But previously, we just like academic school project at lab. So afterward, like HY, we call it HY. It's our CEO decide to put the effort to make this school project to be like
wow.
So it's yeah, the project
That's
is
pretty amazing.
a longer story, but actually for the company it's from 2015.
Were you there from the beginning? Was it?
No, actually I'm not. At that time I still like try to finish my PhD degree. It's a hard time there.
Okay.
Yeah, thank you for all this question. Yeah.
Yeah, anybody else? I definitely remember over 10 years ago, I used to do consulting, and I remember being hired for a project where, you know, the project was specifically to do all of that. You know, there were sources of data in different factories, and we had to bring it all to a central location somewhere in Texas. And we wrote the whole system to transfer all that data. So we were, this is a good 6 years before Alluxio was founded. So this definitely seems very cool. And you're right? You're definitely moving data that you're never going to use.
There is a question in the chat.
Yeah, could you please clarify the situation when one of the region is not accessible for the replication, and how your project overcome that obstacle? It's a good question. Actually, we never think about it. I mean, most of the region actually is you can do the replication, and at least you can access the data. If we cannot access the data, we can do nothing there. But if once you can access data, we provide the better granularity control, and we don't need you to manually to do the replication and do all this kind of work from the one region to another region. And I'm not sure it's answer your question. And yeah.
I guess, is it like an error condition? Can you say, I want to do a query, but if one of the regions is not available, then I should not be able to run the query, or have some kind of tolerance that it doesn't matter? So like, do you bubble up the situation?
No,
so
actually,
that at least
we don't take care of that situation, because in that situation, it will be more work for you to do the backup, and you do the disaster recovery from this kind of thing. And what we can provide, like for example, if you mount two different, maybe you mount one with the HDFS cluster and mount one with the S3 cluster. Actually, we still provide the ability for write through Alluxio together at the same time to these two different storage cluster to do one replication there. But if that replication not write through the Alluxio, we can do nothing with it. Yeah. Yeah, thank you.
Oh. I'll wait a few minutes in case anybody thinks of another question.
Yeah, back to the topic. Actually, previous I know many companies like working, especially at the database level, and do all this migration, especially when you have the MySQL database. It's like super hard to do the migration. Yeah.
What about like the other thing I remember, I mean, I did very little work in sort of the Hadoop ecosystem, but I do remember that like a lot of the queries were very slow. I don't know like what aspect made them so slow, and if that would be helped by, if you put Alluxio in the middle, does it actually speed up queries that otherwise would be really slow, or does it not impact that?
Actually, to my opinion, like the slowness for the Hadoop ecosystem is actually Hive is not so slow if you do the ETL job and all this kind of thing, because actually the only problem is like a MapReduce model, you only can do MapReduce. But for the Spark, this kind of job, they can do reduce. So that means you can pick some of this kind of stage for the ETL job. But when you move the workload from the ETL to the machine learning, just for example, for some machine learning, actually you have to repeat access the data set. So at that time, like Spark can store the intermediate data and also save a lot of time from that. This is from the computing engine perspective. But for the storage perspective, the slowness for the Hadoop system in the cloud environment, especially in the cloud environment, is they cannot guarantee the locality anymore. So previous, we have called hyper-converged model, like you have the data node together with MapReduce computing node, and you can access the data locally. But in the cloud environment, you have to access the remote data, even you are in the same region. Actually, in your EC2 instance, you don't have sufficient storage and you don't want to pay for that money. But at that time, just we talked before, Alluxio provides something called co-located deployment. Once you access the data from the storage to the compute, actually we will catch data there. So next time when you want to do all this kind of work, you don't need to fetch the data again. So actually it will be two layers from the compute and the storage. Yeah, we are mainly solve the storage problem compared to the compute problem.
And then does it have any impact on strategies around data cleanup and where that happens?
Oh, yeah. You mean the data cleanup is at Alluxio layer, or you want to clean the persistent data?
Okay, I mean, does it? I guess I don't really. Yeah, I don't really know, because I don't know that I have enough experience to know what are the different ways that people are approaching data cleanup. But does it make a difference? Can people think about doing data cleanup differently than the more traditional ways, I guess?
I feel people still do it in very traditional way. For example, you generate a lot of smart file, you want to compact them. After some time, people still like doing it asynchronously to merge all this file. And people still using a lot of ETL tool. I mean, it's a lot of innovation there for the ETL to the ELT or whatever. Like people still using this kind of method to do all this kind of cleaning data for the business needed. Yeah.
Cool.
Cool.
Thank
Appreciate
you.
that.
Thank you very much for all this education. I'm really curious and I'd like to know more. So I'll follow what you were saying before about the way to get started.
Yeah, really appreciate it. Yeah, thank you everyone for joining this seminar. Yeah, if you have any questions, feel free to select me at the community channel.
Thank you.
You.
Yeah.
I'm gonna stop the recording now.